Welcome to the DIY Honda Garage channel. DTC P0327 relates to the knock sensor circuit exhibiting low voltage on Honda Accord models from 2012 to 2017. The knock sensor is a critical component mounted on the engine block. It detects engine knocking by measuring vibrations caused by abnormal combustion. The sensing element is piezo-ceramic, transforming these vibrations into electrical signals. These signals inform the powertrain control module, PCM, to adjust the ignition timing for optimal engine performance. A malfunction occurs when the sensor output voltage drops below a threshold of 0.20 volts for more than 2 seconds, prompting the storage of this diagnostic trouble code. In conclusion, understanding DTC P0327 and the role of the knock sensor is essential for maintaining optimal engine performance in the Honda Accord models from 2012 to 2017. The knock sensor directly impacts ignition timing, and any failure in the circuit can lead to performance issues and engine damage over time. A systematic approach to diagnostics, starting from verifying ignition conditions to measuring knock sensor output, is crucial for accurate repairs. Preventive maintenance practices, such as regular inspections, can minimize future risks. Overall, being proactive about diagnosing and repairing knock sensor issues ensures a healthy engine and reliable vehicle operation. The knock sensor, which is pivotal for detecting knocking, is located on the engine block. Its primary role is to monitor vibrations produced by engine knocking and convert those vibrations into electrical signals using a piezo-ceramic element. These signals are sent to the powertrain control module, PCM, which uses the information to optimize ignition timing. By adjusting the timing based on detected knocking, the PCM ensures that the engine runs smoothly and efficiently. If the voltage from the sensor dips below 0.20 volts for 2 sequential seconds, the PCM interprets this as a malfunction and stores the P0327 error code. Understanding the knock sensor's location and function is essential for diagnosing issues accurately. Several factors could lead to the P0327 error code being triggered. Firstly, a failure of the knock sensor itself may occur due to age, wear, or physical damage, leading to incorrect voltage readings. Secondly, a short to ground in the knock line can interrupt the normal signaling process. This short can occur due to wiring issues or corrosion, affecting the communication between the sensor and the PCM. Additionally, an internal circuit failure within the PCM can also contribute to this issue, meaning the PCM fails to interpret the knock sensor's signals correctly. These potential causes highlight the importance of a thorough diagnosis to pinpoint the exact failure point. When experiencing a P0327 error, several symptoms may manifest. The most glaring indicator is the illumination of the malfunction indicator lamp, MIL, on the dashboard. This light signifies that the engine control system has detected a fault. You may also encounter engine performance issues, such as reduced power or poor fuel efficiency, since the PCM cannot optimize ignition timing effectively. Furthermore, you might notice rough idling or audible knocking noises, which reflect incorrect combustion timing. These symptoms collectively indicate the necessity for immediate diagnostic and repair actions to prevent further engine damage. The first step in troubleshooting the P0327 DTC is to verify that the ignition switch is in the on position and that the engine is started correctly. This ensures that the powertrain control module, PCM, is powered and ready to monitor the knock sensor's output. The PCM must be capable of receiving signals from the knock sensor to assess its functionality. Confirming that no other active DTCs are set is crucial, as these could interfere with the diagnostic process. If the ignition switch is properly engaged and the engine has started, you can proceed to the next troubleshooting step safely. Any discrepancies noticed at this point must be rectified before continuing with diagnostics. In the second troubleshooting step, you will need to check for any active DTCs in the vehicle's onboard diagnostic system. Utilizing a scan tool can assist in identifying any existing codes, as these may indicate underlying issues requiring attention. If the diagnostic report shows any additional fault codes like P0328, this might prevent the monitoring for P0327 from running effectively. Clearing any pending DTCs can ensure that they do not affect the current diagnostic results. Once the system is clear of other active codes, we can pursue further testing specifically related to the knock sensor circuit. The third troubleshooting step involves using the HDS Honda Diagnostic System parameter to measure the knock sensor voltage output. You need to ensure that the voltage remains within appropriate limits during both idle and varying engine speeds. Monitoring this output allows the technician to confirm if the sensor is operational. The expected voltage should be above the malfunction threshold of 0.20 volts. If the readings fall below this threshold, it indicates potential sensor failure or wiring issues. Accurate measurement and assessment of this voltage output are fundamental in determining the next steps in the diagnostic procedure. After completing necessary repairs based on diagnostic results, the final repair verification for DTC P0327 involves clearing all DTCs using a scan tool. Following this, it's crucial to perform a test drive with the vehicle, allowing it to go through 3 consecutive trips. This procedure ensures that the adjustment made allows the PCM to retest and confirm the functionality of the knock sensor system without any reoccurrence of the DTC. If the mill does not illuminate during these trips and a new scan confirms no DTCs are present, then the repair can be deemed successful. This verification step is essential to affirm that the issue has been adequately resolved. To minimize the likelihood of facing the P0327 error code in the future, implementing preventive maintenance is key. Regular inspection of the wiring connected to the knock sensor can help identify issues such as fraying, corrosion, or short circuits before they lead to sensor failure. It's also important to check the physical condition of the knock sensor itself, as dirt, grime, or damage can impair its function. Consider performing scheduled diagnostics to monitor the performance of the PCM and its ability to read knock sensor signals effectively. Keeping both the electrical and physical aspects of the knock sensor system in good condition can significantly extend the sensor's lifespan and reduce repair instances. Please like and subscribe to the channel. See you next time.